Good evening, everyone. Thank you for joining. So let's start today's session. Good evening. I'm Rahul Chaudhary. I'm PMRF PhD scholar from IIT Madras. I'm a PMRF NPTEL TA for this course, EMI, EMC, and Signal Integrity. So this is our week 6 live problem solving session. So in these sessions, what we are doing is we are solving few problems which are related to the previous week topics that have been covered, and the idea of these sessions is to help you solve the assignment problems for week 6 or whichever week the course session is going on. So I won't be solving the exact same problems, but the problems are similar to what has been asked in the assignments. So the idea is that it will motivate you to solve the assignment problems. So from today's session, I will be giving you a few minutes to you guys, so that you can read the questions, and after that I will give you 2 to 3 minutes to solve the problems, and you can answer it in the chat box. Means here in messaging, you can put as a message here, or if you do, you can unmute yourself and you can speak it also. It's up to you if you want to give the answer, and the idea is to you can utilize these minutes, 2 3 minutes, to understand the problem, and then if some doubt is there, I will solve it. If there is no doubt also, I will solve it, but after I solved it, if you still have some doubt, we can discuss it again. So uh, I hope it is like you guys got the idea what I was saying. So let's start with today's session with question number 1. Question number 1 is, consider the following statements. Characteristic impedance of a transmission line depends on per unit length capacitance and inductance. So this is statement 1 or statement A. What it says, it says that characteristic impedance of a transmission line depends on per unit length capacitance and per unit length inductance. And statement B is, for a homogeneous medium, the product of per unit length capacitance and inductance is a constant. So homogeneous medium in the sense, throughout that, let's say wire, the let's say there is a dielectric medium present between the wire 1 and wire 2. For example, if it's a coaxial cable, there is a Teflon or some kind of a dielectric material between the inner conductor and the outer conductor. So if it is homogeneous, that means throughout the length of the wire, this medium stays the same medium, in the sense the dielectric medium. That means its permittivity remains the same. So it is saying that for a homogeneous medium, in the sense if the dielectric medium remains same, the product of per unit length capacitance and inductance is a constant. So I hope you guys got the idea. Now the problem is asking us, there are four options and it is asking which of these two statements are correct. Option A says only A is correct, option B says only statement B is correct, option C says that both statements A and B are correct, and option D says none of the statements are correct. So in this problem what has been asked is, characteristic impedance. So like, you guys take your time, go through the statements and then you can type the answer. Meanwhile I will write what characteristic impedance is. Z0 of a transmission line is represented as Z0. So this is the characteristic impedance, and the formula we have seen in the week 6 lectures. It is LE by C, where LE is per unit inductance, per unit length inductance, or C, and C is per unit length capacitance. So in the lectures and also in transmission line we have studied that these capacitance and inductance values are not the lumped values, they are per unit values, like they are distributed throughout the line. This is done in order to simplify the analysis. Let's say this is a wire, two wire transmission line. So this is line 1, wire 1 and wire 2. So let's say this is 1 unit, it's maybe meter, centimeter, millimeter, or something smaller than that. So whatever the capacitance between these two is, this is per unit length capacitance, and then there will be definitely some inductance will also be there, that is per unit length inductance. So if you now read the statement A again, is characteristic impedance of a transmission line depends on per unit length capacitance and inductance, and if you see this formula, Z0 is under root LE by C. So we can clearly say that a statement, we can see from here that statement A is correct, because this Z0 is the characteristic impedance. Impedance of a transmission line. So it depends on both characteristic impedance as well as per unit length inductance as well as per unit length capacitance. So statement A is correct. And statement B says, for a homogeneous medium, the product of per unit length capacitance and inductance is a constant. So here this term is important, homogeneous medium, in the sense here homogeneous medium means this epsilon r is constant throughout the length of the transmission line. So if you write down this relationship is per unit length inductance multiplied with per unit length capacitance is mu epsilon, and if the medium is homogeneous, mu will be constant, and if it is a non-magnetic material, it will be mu is mu naught, and for this dielectric medium, if it is constant throughout, this epsilon remains constant. That means statement A B is also true. So now I hope you get the idea which is the correct option for this. Yeah, exactly, 1C is correct. Both statement A and B are correct. I hope everybody understood this. If you have any doubt, you can ask me. If it is clear, we will move on to next problem, question number 2. A two-wire transmission line in free space carrying constant current has a center-to-center separation of 130 mils. Determine the per unit length inductance of the line if the diameter of the wire is 6 gauge. So here in this problem, what is given is a two-wire transmission line is there which is in free space and it carries a constant current, and the center to center separation, let's say this is our two-wire transmission line, and the separation between them is 130 mil, and we have to determine the per unit length inductance if the diameter of the let's what is it means wire 1 and wire 2 both are same, and the diameter of this wire is 6 gauge. So I hope the question is clear. So I will just write down what is given in the problem. So we will denote this as S. So S is the center to center separation. So in the problem it is given as 130 mils. So I would suggest you guys to remember the conversion for this, for mil to centimeter or meter, because in the problems most of the questions will be given in mils and gauge. So it's better you remember the conversions, because I don't think it will be given in the problem like how to convert it. So it's better you remember this. So if you convert mils into centimeter, we have to multiply this 130 into, so first into inches 0.001 and then 2.54, then this will be in centimeters, and this diameter of the wire, both wires, is 6 gauge. This also we should write it in centimeter. This is the wire diameter. So this we denote it as RW, means radius of the wire. It will be in centimeters, so 0.03 centimeters. So this is the radius of the wire. Now in the problem we have to find out per unit length inductance of a two wire transmission line in free space. So for a two wire transmission line, in the lectures we have seen that what is the formula for per unit length inductance. It is given by 0.4 into ln S by Rw, where S is the center to center separation between the two wires and Rw is the radius of the wire. So this is the formula, and these are the options. I hope you guys are trying to solve the problems. Just take few more minutes. It's better to do these calculations. So this is the formula, and which is LE. LE is the per unit length inductance of a two wire transmission line, which is given as 0.4 into natural log ln of S by Rw, and in the problem already S and Rw is given. So these are the given options. And one more thing, you won't be allowed to take your calculators in the exam, but you still will have that on screen calculator, so that you can use it. Will be a scientific calculator. So for solving the problems, now you can use your regular calculators. Okay, I hope you guys are able to solve it. I will also solve it here. So 0.4 into ln S is given as, it is given in mils, so we have converted into centimeters, so which is 130 into 0.001 into 2.54. So since both I have converted into centimeters, so I am not converting them into meters, I am directly writing them in centimeters because it's a ratio and both are in centimeters. So this radius of wire is in centimeters, it is 0.03. So when we solve it, we will get 0.9594 microhenry per meter, which is approximately equal to 0.96 microhenry per meter. So this is the per unit length inductance of the two wire transmission line given in the problem. So if you see, the correct option here is option B. I hope everybody understood this. If you have any doubt in this, please let me know.
Sir, can you please explain the conversion of the radius in gauges to centimeter or millimeter?
Yeah, sure. So how we convert them is, there is this conversion factors are there that we have to multiply. So you just have to remember this thing, like how to convert gauge to mm. So I will note it down somewhere here. So one, or let's say 10 gauge is equals to 3.416 millimeters. So this, I guess you have to remember, it's something like that, saying 1 feet is having how many inches? 12 inches. So similarly we can say 1 gauge is 0.3416 into 10 to the power minus 3 meter. So it's easier to remember this. 1 gauge is 3.416 millimeter. 10 gauge is 3.416 mm. This gauge is not any standard unit. We know for length standard unit is in meters. But since in EMI, EMC and these wires, they use this mils and gauge. For the diameter they use this gauge. That's why these EMI, EMC problems are given in this. And since most of the assignment problems, they are not giving the conversion factors, so that's why I'm saying just remember this. Is it clear, Vivek?
So the gauge's diameter, is it diameter or radius directly?
No, gauge is a unit. So it doesn't, on its own, it doesn't mean this is the diameter or radius. Here it is given, right? Diameter of the wire is 6 gauge. Then since this is 6 gauge is diameter, we have converted into RW. RW is the radius of the wire, which is whatever the value comes, we have to divide it by 2. So 6 gauge is not radius here, it is diameter, but this RW is the radius. So let's say if you want to convert this 6 gauge into, first I will convert this 6 gauge into, here itself we will do. Six gauge is the diameter. So if you want to, since in the formula it is radius, right? So RW will be 6 by 2 gauge, which is, it should be 3 gauge, right? So we have to convert this 3 gauge into meter and centimeter or millimeter. So now we don't have to do much, right? We just have to multiply this 3 into 0.3416 into 10 to the power minus 3. Then our answer will be in meters. So when you multiply it with this, 3416 into 3, so yeah, if I am converting it into the correct unit, it is not coming out as this 0.03. So that's what your doubt was, right, Vivek?
Yes, sir. When I converted, it's not coming the right
It
value.
is not coming out as 0.03. It is coming out as 0.1 or something like that, not as a 3.
1.028 into 10 power minus 3.
Yes, exactly. That's what I am also getting. Okay, so maybe whatever the solutions they have given, some issue is there in that. I will recheck that part. So this is not correct here, because I didn't converted them. I just directly taken whatever they have given in the solution and then solve it by taking it as 0.03. Either they have taken this as wrong while solving it, or they have taken this as wrong. But whatever you have done is correct only. This is the correct conversion factor, because in the textbook also you can see this is the correct conversion. So that's why you are solving, then you are getting these errors. It means you are identifying these issues there. So it's good to solve along with me. So I will show you one solved example in the exercise from the textbook where they have used the correct conversion factor. Just a second. So what answer you got after solving it with the correct value of this diameter or RW? Is it in the options or not?
Just 1 minute, sir. I will just
Yeah, you
complete.
just check it. Yeah. So here we can directly do this.
It's coming as 0.4683 microhenry per meter.
0.4683.
Microhenry.
So correct option is option A. Means it is approximately equal to 0.48, right?
Yes, sir.
So the correct option is option A. Because if you convert, they are given as 6 gauge, and you have taken as 3 gauge as radius, right?
Yes, sir. 3 gauge.
So it should be, it's converting something else. So yeah, so this 3 gauge is something around 6 millimeters. So generally they use it for steel. Like what is the diameter of a steel? What is 1 mm in gauge? So it is showing something as 5.827. But in the textbook some other values are given. I don't know why. But we have to take whatever given in the textbook only. Because I can show you the textbook here. Okay, so this is given here. Numerous handbooks from wire manufacturers, because they give this, they don't give the diameter in millimeter or mm somewhere. They just give this in gauge. So list not only the radius and number of strands, but also list an equivalent gauge that roughly represents the overall radius of the bundle of the strand. Wires are represented by gauge, which represents a solid wire of certain radius. Although there are several gauge definitions, the most common in American wire gauge AWG manufacturer handbooks also list that wire radius corresponding to various wire gauges. Wire radii are typically given in English unit system in terms of mils, where 1 mil is, so it is given in table 5.2. So yeah, so either this is a good idea if we convert it into mils first, because this is given as a wire gauge. These are the standard values. Like I can't say there is a 3 gauge wire, 5 gauge wire from my own. These are the standard values, and always in the question either one of these values will be there. Either it will be 1, 2, 4, 6. So for wire gauge of 6, it means the diameter is 184. That is in mils. So but now we know how to convert 184 into mils into, because we, for that we just have to multiply it with 0.001 into 2.54 centimeters. So if it is given the diameter as 6 gauge, right, it's like a wire is 6 gauge, means its radius is, or its diameter is 184 mils. So if I convert it into, so its diameter is 184, first we'll divide it by 2, 92 into, now we are calculating the radius. So now it is, the radius of this wire is 92 mils, and mils we can easily convert into centimeter by multiplying it with 0.001 into 2.54. So the answer comes out to be 0.23368 centimeters. So this is the RW value that we have to use. uh, Vivek, did you use this value or something else for your radius of the wire?
Sir, I used to what you told, sir.
Okay.
Three
So
point.
I referred something else. That was not correct. It's better you
Okay.
use this conversion from the textbook, I am telling you.
Okay.
So this will be standard because all the answers will be calculated based on this. So this one is the correct thing. So it is saying, if ideally what I hope is they should be given in the problem, like 6 gauge means how many mils, at least mils it should be given, because mils is something standard that we can convert into centimeters. So if this wire goes, this is from this textbook from page number 224. So wire gauges and wire diameters. So if it is 6, okay, if it is trended it is something else, and if it is a single solid wire it is 162 mils. Okay, we will calculate it again based on this. Yeah, sorry for this confusion, but it's better we clarify it. Anyhow, that's, otherwise if I just solve the problems it won't be much of a beneficial to you. But now at least we are learning something. Into 162, because I hope this week's assignment problems also the values are only in gauge, right? Their conversion is not given in the problems, right? If anybody has solved the problems for this current week in the NPTEL. So it is what it is if it is 6 gauge, let's say it is 162, so this is the diameter divided by 2, 81. Now if we convert it into 0.01 into 2.54 centimeters, so it comes out to be 0.19845. So both are pretty, so this is the correct value, I think. So if it is a single solid wire, 6 gauge means 162 mils. So I hope you guys have the textbook, and if you don't have it, just take a screenshot of this value, this table. Because somewhere in the lectures also sir has mentioned it what one gauge means. So I will refer to that, and I will note down that also here. So currently I was not able to find any values, but I think in one of the lectures sir has also mentioned it. But now for now time being we will take this as the correct value. So 6 gauge wire means it has a diameter of 162 mils. I will note it down here, and we can resolve this problem by taking that value. So what we are taking is, if it is a 6 gauge wire, its diameter is 162 mils. So this is the diameter of the wire. So but now we need Rw in the formula. So Rw will be 162 by 2, so 81 mils, and with this 81 mils we can convert into centimeter by multiplying it with 0.001 into 2.54 centimeter. So I will note down the final value here. So 81 multiplied with 2.54 gives 0.2057 in centimeters. Now we will use this value to calculate. So LA is 0.4 into ln 0.20574. Sorry, this is S. This should be in denominator. So S is same, it won't change. It's a standard value. So mils is a standard. It, like it won't change from manufacturer to manufacturer. So S is given already as 130 into 0.001 into 2.54, and this is 81 into 0.001 into 2.54. So this is 0.4 into natural log of 130 divided by 81. So we have to take natural log of 130 divided by 81 multiplied with 0.4. So we get something like 0.0023. 0.0023. Okay, still it looks too big, correct, right? I can write this as 2.3, it is milli something is coming, entry per meter. Okay, well, I will check it once What is the problem here? Because when I convert it into the units given in the textbook, I'm getting answer is 2.3 millihenry per meter. But all the options are in micro and pico and not even 0.2 something. Did you also try, Vivek, solving with this?
Yes, sir, I tried, but the
Mm-hmm.
answer is also not matching for me. That is coming as 0.18 microhenry per meter. I converted into radius completely. That is
Okay.
in centimeters.
Uh-huh.
Both the units, that is from gauges. It is as our radius will be 0.2 centimeter and
Mm-hmm.
S will be 0.3 centimeter. I used that.
Because
Then
S
I,
is correct only. Center to center it is in mils. So mil
yeah,
is correct.
I think conversion
Something,
somewhere we
yeah,
are
yeah.
missing.
Because it's not a standard conversion. It depends on manufacturer to manufacturer. But according to the textbook, it is given as if as a 6 gauge wire, it should be 162 mil.
Sir, I'm not sure whether I'm right, but I have noted when sir was
Haha, that is
explaining
more
in
important. Yes. What he told.
lecture 23,
Ha.
there was one problem, ribbon cable 28 gauge
Yes.
wire.
Yes. Ha.
So in that he mentioned 28 gauge equal to 2.8 mm in dia. I
28.
don't know whether it is
So
correct.
according to the textbook, 28 gauge is 12.6. So according to the textbook, I am telling it's in mils.
Mm.
12.6 into 0.001 into 2.54. So it should be 0.03 centimeters dia.
Okay.
So what sir has told?
Sir told 2.8 mm in dia.
Okay. So means this is not correct then.
So I'm also not sure, sir, because
Mm-hmm.
that value was not used in the problem because it was
Ha ha ha. Oh.
irrespective of the dia of the
Ha ha. It's
wires.
not
The separation
been used.
distance was
Yes.
matter.
Understood. Because here in they are calculating this directly in mils also, not in gauge. Okay, I will come back to you with this one. Otherwise, the only issue is with the conversion factor, right? Like we have to find out the correct conversion factor. Otherwise, the formula is correct. So this is the formula for per unit length inductance of a two-wire transmission line. This is correct. S stands for the distance between the two wires, and this RW is the radius, which we have to find it out in centimeter. So we have to find out what is the conversion factor they are using for gauge to centimeter or meter. Okay, also it matters from material to material also. Okay, I will get back to you with this one. For time being, we will leave this problem as it is because the conversion factor is a issue here. We are not sure what this means because it varies from material to material. So as far as I can say, if it is this material, if this line is of steel, 6 gauge is something different, and if it is a copper wire, 6 gauge is something different. Different in the sense it's not a standard unit, it varies from material to material. So I'm not sure which material they have taken, and maybe the conversion factors that we are seeing in the textbook is for some other material. So I will figure it out and come back to you on the next session. But don't worry, we will clarify this. Okay, we'll discuss this thing in next problem, next class. Like I will figure it out, and I will raise a question in the Google group also. Like what is this gauge, and it's dependent on the material, or which material by default we are taking in all the problems. I am guessing for all the problems copper is taken. So for copper, what 6 gauge means is we have to take. And what in the textbook, that earlier the value which I told you was for steel. In the textbook I think it is given for copper, or I don't know, but I will figure it out. Just give me till next session. I will figure it out and let you know. Now we'll move on to next problem. So yeah, thankfully in this problem we don't have to use this gauge or mills. So consider two-wire transmission line in a homogeneous non-magnetic medium with dielectric constant given as 2.06 carrying a constant current. If the inductance per unit length of the transmission line is 1.8 microhenry per meter, determine the per unit length capacitance of the line. I hope the question is clear. So in this problem a two-wire transmission line is given, and what else is given is it's a homogeneous, it's a two-wire transmission line in a homogeneous and non-magnetic medium. So homogeneous means its epsilon means, or its dielectric constant epsilon r remains constant throughout the line, and non-magnetic means its mu is mu naught, its mu r is basically 1, since it is a non-magnetic material. Now we know that what is the multiplication of this thing, Le into C is mu into epsilon, and in the problem what is given is this is given as Le is given as 1.8 microhenry per meter, and dielectric constant epsilon r is also given, which is 2.06, and mu r is 1 because it's a non-magnetic material, and epsilon r is given as 2.06. So inductance per unit length also is given. Le is 1.8 microhenry per meter, and we know that for a homogeneous medium Lc into inductance per unit length multiplied with capacitance per unit length is mu into epsilon, and mu we know is mu naught into mu r, and epsilon is epsilon naught into epsilon r. Since for this problem it is non-magnetic, mu r is 1, and mu naught we know is 4 pi into 10 to the power minus 7. Mu r is 1 into epsilon naught is 1 by 36 pi into 10 to the power minus 9, and epsilon r means the dielectric constant is 2.06, and L also we know it is given as 1.8 into 10 to the power minus 6, 1.8 microhenry into C. So the capacitance per unit length is given by 4 pi into 10 to the power minus 7 multiply with 1 by 36 pi into 10 to the power minus 9 into 2.06 divided by 1.8 into 10 to the power minus 6, and when you solve this, capacitance per unit length comes out to be 12.716 pico farad per meter. So this formula is valid only when it is a homogeneous medium. Homogeneous medium means the dielectric materials remains the same throughout the length of the wire. So I hope you got the idea what this dielectric material means here. If you see any cross section of a coaxial cable, it looks something like this. So yeah, this is what a regular coaxial cable looks like. So this is the normal plastic jacket, this is the metallic shield or outer conductor, and this is the dielectric medium between the conductor 1 and conductor 2. Whatever this two copper things are shown here, right? The central core is the line 1, and the metallic shield means is the line wire 2, and this is the dielectric medium. So if it is homogeneous throughout the length of the wire, then we call it is a homogeneous medium, means this dielectric constant remains the same throughout the wire. So it's just one example for a coaxial cable. Same thing goes for a two wire line, two wire transmission line. So if you match with the given options, the correct option is option number D. I hope this question is clear. If you have any doubt in this, please let me know. So if this is clear, we will move on to question number 4. So again, this is the problem here again. Like this conversion is already not given. So 1.5 5.08 wire is at a height of 70 mil above the ground plane, carrying constant current in free space. Determine per unit length inductance of the line. So we will ignore this once, and but still whatever the formula comes out is correct. So we'll go with the standard formula and try to solve it. So here what is given is a single wire at a height of 70 mils. So let's say this is the ground plane, and this is the wire, this is above, this height is 70 mil above the ground plane, carrying a constant current in free space. So this is free space here. So here epsilon r is epsilon naught. So epsilon r is 1 basically. That's what free space means. So we determine the per unit length inductance for this line. So we have to find this LE. So first height above the ground plane h is given as 70 mils, and the diameter of the wire is 5.08 gauge wire diameter. So I'm just taking whatever the was given in the problem solutions. So there they have taken it as 0.0254 centimeters. Now using the image theory we can find it out. We can assume that there is also second wire using the image theory, and whatever this also will have h is 70 mils. So the total separation will be combination of both. So this is our S. So this is done using the image theory. Like whatever the wire is in front of the ground plane, same wire exists in the opposite plane of the ground plane, and whatever the distance means that second wire is acting as the second wire, actual second wire, just to solve the problem. So this is one assumption that we are taking using the image theory. Image theory we can write this as is 2h, means the separation between the two wires. The second wire is imaginary. So S is 2 times of 70 mil. So S comes out to be 140 into 0.001 into 2.54 centimeters. Now we know that per unit length inductance of a line above ground plane in free space is given by mu by 2 pi into ln s by rw. So mu is 4 pi, since it's a non-magnetic material, so mu is mu naught into mu r is 1, so mu is mu naught here for free space, and divided by 2 pi into ln into s is 140 into 0.001 into 2.54 divided by the radius of the wire. This thing I have taken was given in, and I am taking it as 0.0254 centimeter, but I will clarify this why it is it correct or not in the next session. So let's assume it to be correct and solve the problem. 0.0254, because all the options are calculated based on this value only. So when you solve this, the solution comes out to be 0.5278 microhenry per meter. This is inductance per unit length for a single wire. If you match it with the given options, the correct option is option B, 0.527 microhenry per meter. So I hope this formula is at least clear, except this issue with this gauge 5.08 gauge, what it will be in centimeters. This I will clarify, I will figure it out what it is by next session. Okay, now we'll move on to question number 5. For question number 5 and 6, the data is same, means the same two-wire transmission line is used. So the common data is, consider first case where the per unit length inductance of a two-wire transmission line in free space with center to center separation S with equal wire radius, means Rw is same for both the wires, carrying constant current to be denoted as, so in case 1, inductance per unit length is denoted as Le1. Now there is a second case, we have to consider case 2, where a single wire transmission line, okay, here is a two wire transmission line, here is a single wire transmission line, which for that the inductance per unit length is taken as Le2, where a single wire transmission line above an infinite ground plane at a height h carrying equal current as case 1. So in case 1 and case 2, both transmission lines are carrying the same current, and it has a inductance per unit length denoted as Le2. Okay, now the question 5 is asking if inductance per unit length for the two wire transmission line in case 1 is equals to 4 times that of inductance per unit length Le2 in case 2, then which of the following relationship holds true? And we have to consider the wire radius to be same in both cases. So I hope you got the idea, because for both the cases, we have seen what is the formula for finding out this inductance per unit length. Le1 is inductance per unit length for a two wire transmission line, and it is given by mu by pi natural ln s by rw, and where this s is center to center separation between the two wires, and rw is radius of the wire. So S is center to center separation between the two wires, and Rw is radius of the wire, which is same for both the wires. And for case 2, Le2 denotes inductance per unit length for a single wire transmission line above a infinite ground plane. Single wire transmission line. The formula for that is, we have seen in the previous question, is mu by 2 pi ln 2h by Rw. So where this h is the height of the wire above the ground plane, and Rw is same as that's radius of the wire. Now we just in the problem it is given that Le1 is Le2. So Le1 is mu by pi ln S by Rw is equals to Le2 is mu by 2 pi ln 2h by Rw. When you solve this, and it is 4 times, so we have to multiply this 4 here, and when we solve this, what we will get is this mu by pi and mu by pi gets cancelled out. It is 2 here. When we solve it, h comes out to be under root s into Rw by 2. Sorry, this 2 is outside the under root, and when we solve this, we can take a whole square both sides, so it becomes, since it is given the relation between s and h, so s is 4h square by Rw. So this is the relationship between the separation between center to center separation between the two wire transmission line and the ground plane distance for the single wire transmission line, in the case where both are carrying the same current. So if you match it with the given option, the correct option is option number D. I hope this is clear. If you have any doubt in this, please let me know. So if this is clear, we will move on to question number 6. Here also the same case is there. Means two cases are there, where one is two wire transmission line, the other one is a single wire transmission line. So now in this, the radius are different. Different means, in case 1, the two wire transmission line, both wires have the same radius, which is denoted as Rw1, and in case 2, Rw2 is Rw1 by 1.5. Means it is smaller than what is Rw1. Whatever the wire radius is in case 1, in case 2 it is smaller by 1.5. It's 1 by 1.5 times smaller. So in if radius of wire 1 and wire 2 in the two wire transmission line is denoted as Rw1, and Rw1 of superscript 1 is 1.5 times with Rw superscript 2, where Rw is a wire radius and the superscript denotes case number considering. So here we have to consider one more thing. Instead of Le1 is 4 times, now in question number 6 it is 2 times of per unit length capacitance of case 2, Le2. Now we have to determine which of the relationship is correct. since we already know what are the formulas are, we can just directly write it down here as mu by pi. For a 2-wire transmission line, it is S by Rw with superscript 1 is equals to, now since it is 2 times, we are multiplying this 2 here with the formula of per unit length inductance for a single wire transmission line, which is mu by 2 pi ln 2h by Rw2, since this time they have a different radius. So when we equate them, and this Rw2 is, or Rw1 we can replace with, since these both goes away, S by 1.5 Rw2, because it is given as Rw1 is 1.5 times of Rw2, and this stays the same, Rw2. When we equate them, what we will get is S is 3 times of H, because this Rw2 Rw cancels out, and 2 into 1.5 is 3. So here the relationship between the S and H is S is equal to 3 times of H. So if we match it with the given option, the correct option is option C. I hope this is clear. If you have any doubt in this problem, please let me know. Okay, this issue, Ines, we will discuss in the next session, the conversion one. Rest, if you have any doubt related to question number 5 and 6, please let me know. If it is clear, then we will move on to question number 7. Consider a coaxial cable having inner wire diameter as 5 gauge, shield radius as 95 mm. Determine the relative permittivity of the shield if the capacitance per unit length is 75 picofarad per meter. So here also we will take this, what is given is a coaxial cable. Its inner wire diameter is given as, so if this conversion is correct or not, that I will let you know in the next class. Diameter is 5 gauge, and the Rw comes out to be 0.025 centimeter, and the shield radius Rs is given as 95 mil. The shield radius means, I have shown you a transmission line, right? A coaxial cable, which looks something like this. There is an inner conductor, then there is this dielectric. I will use the another color. So what it means is, this is the inner conductor. I'm denoting it in the red color, and then there is a dielectric in between. And then there is this. This is the shield. That this shield is also a metal. So this is shield, and this is the inner conductor or inner wire. So the shield radius is given as 95 mils, and the radius of the inner wire is denoted as Rw, which we are taking it as 0.025 centimeters. So we know this 95 mil, we can write it as 95 into 0.001 into 2.54 centimeters. And in the problem, the capacitance per unit length is given as capacitance per unit length for this coaxial cable is given as 75 picofarad per meter, and we have to find out the relative permittivity of the shield. Means this green color, what is the epsilon r. So we know for a coaxial cable the capacitance per unit length is given by 55.56 epsilon r divided by ln rs by rw, where rs is the radius of the shield and rw is the radius of the inner wire. So in the problem it is, the c is given, epsilon r is something that we have to find, the relative permittivity. So when we solve this, we will get epsilon r as 75 divided by 55.56 into ln 95 into 0.001 into 2.54 divided by 0.025, and when we solve this, we get epsilon r as 3.06042. And when we match it with the given option, the correct option is option number C. I hope this is clear. If you have any doubt in this, please let me know. Okay, now we will move on to question number 8. So here in question number 8 and 9, same coaxial cable is there. So the data is common. So manufacturer specification of a coaxial cable is the inner wire diameter is 6 gauge, shield radius is 42 mils, characteristic impedance of the coaxial line is 40 ohms. So Z0 is given as 40 ohms for this coaxial cable, and the velocity of propagation, like at the speed at which the wave is traveling through this wire, is 53% of free space velocity. So free space velocity is the speed of light, means c. Now in question number 8, we have to determine per unit length inductance of the line. So in this problem we have to find for this coaxial cable inner wire diameter is given as 6 gauge, so again I am taking this radius as 0.3 mm, like in the second problem same thing we have taken, right? Which I am not sure is correct or not, but I will get back to you in the next class and we will clarify it. But now let's assume this to be the value as 0.3 millimeters. This is the radius of the inner wire, RW is 0.3 millimeters, and the shield radius is RS is 42 mil. So this RS can be written into centimeters. Now in the problem we have to find the per unit length inductance for this line. Means LE we have to find, which is given by mu by 2 pi ln RS by RW. So this, since that material is non-magnetic, we are taking mu as 4 pi into 10 to the power minus 7 divided by 2 pi ln RS is 42 mils. In centimeter it will be 0. Multiplied with 0.001 into 2.54 divided by 0.3 into 10 to the power minus 1, because we both are in centimeters now. So when we solve it, we get the per unit length inductance as 0.253 microhenry per meter. If we match it with the given option, the correct option comes out to be option number A. So I know the only doubt is right, why this RW is 0.3 mm, or like how it came, the conversion factor. That we will discuss in the next session. If there is some change, we will solve it again, and if we will check these options are correct or not. Apart from that, I hope this question is clear. We will move on to question number 9. So data is same, means the same coaxial cable. We have to determine per unit length capacitance of the line, and also check whether the manufacturer specification is consistent or not. So in the problem, two things have been asked. First is pretty simple, straightforward. We have to find the per unit length capacitance of this coaxial cable. So velocity, in the problem it is given the velocity of propagation is 53% of free space velocity. So what this means is V is 0.53 times of C. So this is the velocity at which the wave inside the coaxial cable is traveling. So from this, what we can find out is, we can find out what is the permittivity, relative permittivity of the material between the two cables. Means velocity in a medium is given by this formula, C by under root epsilon r, because this depends on the dielectric permittivity or relative permittivity of the material. If it is free space, it is V is equals to C. But if it is some dielectric material where epsilon r is not 1, the velocity will be less than the speed of light. So when we calculate it, epsilon r comes out to be C by V whole square, and we know that V is 0.53 times of C. So when we solve this, epsilon r comes out to be, and we know what is the value of C is 3 into 10 to the power 8 meter per second. So when we solve this, we will get 3.559 or approximately equal to 3.56 as the relative permittivity of the material. So now we can easily calculate the capacitance per unit length C is 55.56 epsilon r divided by ln RW by RS by RW. So first the shield radius should come, RS, then inner wire radius. So when you solve this, now we know what epsilon r is. It's 3.5. We will substitute it here, multiplied with 3.56, and this ratio comes out to be 42 into 0.001 into 2.54 into 0.3 into 10 to the power minus 1. So when we solve this, capacitance per unit length comes out to be 155.91 picofarad per meter. Now this is the first part of the problem, because in the question they are asking also, like, check whether the manufacturer specification is consistent or not. So if you read through it, there are different things are given by the manufacturer as a specification of this coaxial cable, means the diameter and the radius and this velocity of propagation. So I am pretty sure these things will stay the same, but we have to find out the main specification is this characteristic impedance Z0 is given as 40 ohms. Is it correct or not? Is it consistent or not? So we have to find out characteristic impedance. Characteristic impedance of this coaxial cable, which is given by Z0 is equals to under root LE. LE is inductance per unit length divided by capacitance per unit length. So in previous problem we have solved what is the inductance per unit length. It was 0.253 into 10 to the power minus 6, and capacitance per unit length is 155.91 into 10 to the power minus 12. And when we solve this, we will get 40.28 ohms, which is approximately equal to 40 ohms. This means the characteristic impedance of the coaxial line matches with the manufacturer in specifications. So this Z0, that is the characteristic impedance of this characteristic line of this coaxial cable, matches with the manufacturer specification. So now if we match it with the given options, the correct option is okay. So all the options are given in picofarad per feet instead of per meter. So here we have to convert it into feet. So as a conversion, 1 meter is this is some standard units, so it's not there won't be any ambiguity here. So 1 meter is 3.2804 feet. So this we can easily convert it into farad per feet. So when you convert it, it comes out to be 47.52 picofarad per feet. Now if you match it with the given option, so correct option is option A. I hope this is clear. If you have any doubt in this, please let me know. If it is clear, we will move on to question number 10. Consider the following statements. Here three statements are given. A radiated susceptibility is a near field phenomena. Statement B is equivalent. So this is something related to the lecture number 29 and 30. If you have seen both the lectures, it will be easy for you to directly answer this. So statement A says that Radiated susceptibility is a near field phenomena. If you recall the lecture 29, professor has clearly mentioned if it is a near field phenomena, it is not radiated susceptibility, it is a crosstalk between the two things. That means if two transmission lines or two strip lines in a PCB are very close by, and if there is a crosstalk happening or any interference is happening, that is called as crosstalk. So statement A is not true because radiated susceptibility is a far field from a phenomena, not a near field phenomena. So we can cross it out. Option B, statement B says an equivalent circuit model for radiated susceptibility is based on the assumption that length of the wire should be very much less than the operating wavelength. Yes, option B is correct. If you recall the lecture, first assumption that we made was the length of the wire is much less than the operating wavelength, means the lambda. So option B is true, and option C is not correct because crosstalk is not a far field phenomena. Crosstalk happens between two cables when they are really close by, so it's a near field phenomena. Radiated susceptibility on the other hand is a far field phenomena. So if you match with the given option, so only statement B is correct. So the correct option is B. If you have any doubt in this, please let me know. And that doubt related to this conversion of this gauge into meters or millimeter, I will clarify in the next session. So I will go through the textbook and I will solve few problems in the exercise. Then I will match it with the solutions that are given. And I will also raise one doubt in the Google group. So by next class it will be solved. So or by that time you can also raise this doubt in the Google group. Discussion forum is there in our NPTEL course portal, right? You can also raise this doubt. I will also raise it and I will ask for some clarification there also. So that's all for today's session. Thank you for joining. If you have any doubt, you can ask me. Otherwise, this is all for today's session. Thank you.